So I have here my Loto. This is a PC-based oscilloscope, and I need an extra USB port. Let me find the USB in here and set it up. Set it up. I actually have several videos of the OSC oscilloscope. Right now, here with me is the OSCF4, which is a 4-channel oscilloscope. What I'm going to do is to measure the LED flashing rate. Ada bang istorbo piman. Kanyak dia tuh na. Kakararag na ka na. Aya po piman. The ground is this one, and the pincherin is the next one. So there you go. You cannot just put the oscilloscope in there, but you need an extra kind of connectors like the pins in here, and the GND is here. There you go. It's the setup in here using the OSCF4. Oh, I can see the mouse in there. No, not the mouse, the cat. Just disturb me. She's doing the thing. That's her business. So going back in here, this is the Arduino Uno. And you can see in here, this is the GND. And this is the black connected to the ground of the oscilloscope. And this is the pincherin in here. Pincherin is just over there, and pincherin is connected to the yellow cables and connected to the positive oscilloscope, and then input to channel A. So this is the pincherin. It is blinking at 1 second. Once again, it is OSCF4. This is a 4-channel oscilloscope. This is 1, 2, 3, 4, and I'm only using the channel A right now, or the channel 1. Hey, cat, come over here. Come over here. Come on. So let me find the OSCF4 here. This is the shortcut on the desktop. So I'll double click it and it invoked the OSCF4. It's basically a little bit different from the OSC482. And what I can see in here is to start the device. And let me go. So 1 second. I'm going for maybe 500 millisecond. This is the LED on, LED off, LED on, LED off, LED on, LED off. So I'm going to put the time division into 1 second, so it is easier for me to take a look at it. So this is the square wave, as you can see in here. This is LED on at about 4 volts, LED off, which is at the GND. And I'm going to put that into the storage mode. Let me do that into the white background. And I'm going to invoke the cursor right now. So let me put the A cursor into the plus, going to turn on the LED. And then that will give me about from A to B. So this gives me about 1.047 seconds. So basically, it's the signal for the Arduino is accurate. So 1.047 seconds. Let me see again for the third time. This is the first LED turn on, LED off, LED on, LED off. So let's measure in here. This is C to D, and we got here the measurement, which is C to D, and this is C to D is 1.016 seconds. Wow, that's pretty awesome, I should say. So the Arduino timing is, I would say, accurate, and that is something that convinced me that 1 second, 1000 milliseconds, which is in here. And just for the sake of understanding, let me put that one into a nice capture. I want to save that into a text file. I'm going to go to desktop, Arduino in here, and I put that into audio programming, 1 second capture. Let's just say 50 millisecond. So this is 50 milliseconds. Download that. Done compiling, uploading. Now it is blinking. And start again the oscilloscope. Let me go to about 100 millisecond. So this is the capture for 100 millisecond. Put that into a full screen mode, and then stop the device, and then I'm going to measure the timing. So the first LED on, it will give you about 50.456 milliseconds. So it's pretty close, or I should say it's exactly 50 milliseconds. So this is the first one. Turn on the LED, turn off, turn on, turn off, turn on, turn off. So I'm going to measure it in here. The C to D cursors, it's measuring like about this is the C to D is a 49.755 milliseconds. Awesome, this is absolutely okay to me. So 50 milliseconds in the Arduino, here 50 milliseconds, and exactly what it is outputting here. So I'm going to save that one into the Arduino. My program is in here in program one. So that is 50 millisecond capture on OSCF4. There you go. I'm convinced 1000 millisecond is 1 second and 50 millisecond is 50 millisecond based on the sort of the OSCF4 virtual oscilloscope from Loto. Perfectly convinced, perfectly convinced. Second, so there you go, 20.329. This is 20 millisecond. So there you go, 20 milliseconds, the fast blinking here at the LED, and I can see clearly here at the OSCF4 oscilloscope. That's pretty cool, that's pretty cool. I'm convinced now that my program here at 20 millisecond delay, it's giving the right output based on the oscilloscope capture, because in here I cannot exactly say that it's 20 milliseconds. All I can see is that it's blinking faster, but I cannot justify if it is really 20 milliseconds. So programming the microcontroller with the Arduino Uno, my program is exactly being outputted in a real world. This convinced me right now. Success, guys, success, success, and success. 20. Now you see those cat over there? It caught my attention. They are sunbathing right now. Those are the lovers. They have some kind of deficiency with the Loto instrument, the OSC4828, and the latest one I have here, the OSCF4. This is a 4-channel oscilloscope, while the OSC482 is a 2-channel oscilloscope. Yeah. I love them. It goes with me wherever I am. Right now here in the Philippines. And behind the heart of this video series on the Loto instrument, I keep continue using and exploring those so-called add-on modules, like the differential modules, which is you can measure on any point of the circuit differentially, not with respect to ground, which is really good for Class D power amplifier with a bipolar tie-load. I already have several of these modules, as well as like modules that can let you to expand your input range to at least 80 volts with the oscilloscope probe right now with the times 10, that is only for about 50 volt, plus or minus 50 volt, but with some modules like the IDM03, it can allow you to go up to 80 volts, plus or minus. And there are other modules that you can actually incorporate to the OSCF4 or the OSC482 up to 600 volts if I'm not mistaken. There are also current proofs that you can use it to measure the current accurately from 100 microamperes up to 60 amperes. I have those modules, but I don't have the leverage and the luxury time to use them for real applications. What I have right now is the real applications. The OSCF4 goes with me on my travel to the Philippines and help me to analyze what is all about my programming on the Arduino, about the timing for right now. And this is really, really pretty cool. And by the way, guys, the next thread in my channel is going to be the Arduino HMI. The Arduino is a kind of project that I thought of doing it like a kind of a controller for power amplifier. That's why I call it HMI, the human machine interface on the front panel of your amplifier, like the one I have in the Nathan Winter Camp and the DR700W Class D power amplifier. I hope you will going to visit once again my channel to take a look at what is my next project. Arduino HMI. From the comfort of having a DIY gadgets like what I have here right now, going mobile goes with you wherever you are in your travel, like my travel here in the Philippines. Welcome to the Philippines, by the way. It's Ferdinand Dandy here of the DR100W Class D power amplifier. Bye for now and see you in the next video. By the way, guys, I wanted to greet you with a local dialect. Just tikumoyog. Just tikumoyog.